where, yes, there's been 23 plus civilizations throughout history, and most of them have collapsed within 300-400 years because they have gone into that simplicity, degraded, mined their soil systems to the point that those soils can no longer retain the water, make those nutrients available, grow productive food. And so obviously that civilization, that population collapses unless it gets like us and becomes very, very warlike and then invades and colonizes the land of other people. So we just exploit more land. And that's in a sense what we've been doing through history. We've just been either dying, collapsing, or going into wars to colonize other people's land. But now we've reached the end of the earth. We've got a finite earth. There's no more land to colonize and exploit. So we're really down at that basics now. And unless we get wise and understand that, yes, we have to manage and regenerate the land that we've got, it's cactus.
Welcome to the Real Organic Podcast. I'm Linley Dixon, co-director of the Real Organic Project. We're a grassroots, farmer-led movement with an add-on organic food label to distinguish soil-grown crops and pasture-raised livestock under the organic seal. You just heard from Water Jehne, an Australian soil scientist who has been an important voice for paying attention to Earth's water cycles as we work to mitigate the climate crisis. Before we dive in, I'd like to thank those of you who have written us to let us know how much you like our show. The fan mail is really motivating and inspiring to all of us, so thank you. Also, please leave a rating and review of our podcast as it will help us grow our audience and share our message farther and wider. Okay, now let's get back to the conversation between my co-director Dave Chapman and Water Jehne.
My guest today is Water Jehne, and Walter is a soil microbiologist from Australia, and I would say a longtime teacher for me, and he's really been a real gift. You know, he's taught me so much about soil and climate and nutrition. So also I'm very proud that he's on the advisory board of the Real Organic Project. So Walter, welcome.
Well, thank you very much, David. And yes, wonderful to be here and having a wonderful conversation. So look forward to it.
Wonderful. So the symposium that we're working on is going to have three sessions that are going to be particularly related to things that you and I have talked about for many hours now. And the first one is about healthy soil, and the second one is about climate and agriculture, and the third one is about soil and nutrition. So, you know, this is your bailiwick. So let's start with healthy soil, and if you could tell me how you would describe healthy soil, and we'll get into why it's important, but what is healthy soil?
Right, David. Basically, if we start with healthy soil, and we'll go right back to the fundamentals, soil is the crucible of life. Okay, is basically a medium from which basically life evolved on this, terrestrial life evolved on this planet. And basically it's the medium which supports the hydrology, the biosystems, all the plants, all the animals, all our food systems. And actually it is basically the governing, crucible of life. But more importantly, soil, healthy soil, is our only point of agency that we as humans have in terms of the planet, in terms of the universe. When you think of it, yes, we've got sunshine, CO2, water, nitrogen in the air, but they're just in the air. And so the only way we actually harness and use and interact with those things is through what happens from soils. You know, it's the capacity of soils to grow plants, and then, of course, the biosystems which we fundamentally depend on. So it's really, the foundation of nature, soils. And of course, on a terrestrial basis, yes, it was a starting point of life on land. 420 million years ago, there was just rock and ocean. Life had evolved in the oceans from 3.8 billion years ago, but basically there was no life on land. It was just bare, arid, dry rock. And so it was the fungi growing up from the estuarine edges onto that rock, solubilizing it, breaking it down, leaving behind organic detritus in the crevices of that solubilized rock that created soil. And so that soil was the actual foundation, starting basis for life on land, because from that soil, it was able to then infiltrate, retain moisture, and of course then progressively allow plants, initially, of course, the fungi, lichens, mosses, ferns, liverworts, cycads, and allowed then progressively plants to colonize that land, ever more increasing the organic deposition, forming ever more soils. And so very rapidly in the Carboniferous, we then basically had plants developing soil, and of course the soil allowing more and more plants to develop. So really it's, in every sense, healthy soil, organic soil, the crucible of life on this planet.
So a couple things there, and I want to pause. I want to slow it down only because I know that many of the people who are going to be coming to the symposium, we might say, are civilians. They're just regular people. They might live in the city, and mostly their idea of soil is it's dirty and it gets on your hands and you wash it off. So you're suggesting something in which we have a long relationship with and a profound relationship with. One thing that you said is that plants make soil and soil makes plants. So I think that relationship predates us. Could you talk about that a little bit?
Well, absolutely, it predates us, and basically it is what formed us, okay? Because we are just animals that then evolved to eat those plants. You know, we evolved in those trees as animals, herbivores, eating those plants that were grown in that soil. So in a sense, in all the religions and what have you, mythology, yes, we are soil. You know, we come from the soil. And that's literally scientifically true. It's really basically, you know, like soil creating the opportunity for microbial and then plant life, that evolving into biosystems or the whole vegetation. And we are simply animals that evolved to eat that vegetation. And so we are just a part of that continuum, totally dependent on those primary soil processes for our existence and survival.
Okay. In modern agriculture, there are people who would doubt you, I believe. But
okay, I think we can get into that. Modern agriculture's then extracted that and sort of said, look, can we extend ourselves beyond soils? Can we manipulate nutrients? Can we manipulate moisture? And can we grow plants in this artificial hydroponic situation? And the answer is, of course we can, but we lose. We have to then ask the question, what are we losing that we get in that essence of soils? I mean, have we got the same capacity in these artificial situations to access all those 50 plus essential nutrients that are involved in life at the right concentration, forms, ratios, balances? And the answer is no, we can't. And so we're missing out. So yes, we can artificially move forward, but we can't actually replicate what nature did naturally through soils. We can talk about later on, it's a bit more sophisticated processes that control that. But soils is still the basis of us, our whole existence, but basically the hydrology on the planet, the climate of the planet, the food production of this planet, and our very, very survival and future on this planet.
So can we talk, one thing that people talk about is living soil and the life in the soil. And again, I think to a civilian, this would, you know, people say the word, oh, living soil, but they don't quite understand what that means. Many people, perhaps most people in America today, don't understand what that means. So could you try and describe that in a way that somebody who's not very well trained might understand?
Okay, let's break that down from two angles. One is just numbers or quantity, and then more importantly, let's look at that as processes as well. So if we just look at life in the soil from a quantity point of view, take a teaspoon of soil, a gram of soil, and it contains up to 10 billion organisms in that soil. These are microbes, bacteria, actinomycetes, fungi, nematodes, you know, the whole range of microbial life in that soil, 10 billion organisms in a gram of healthy soils. And so enormous diversity. And of course, they're all basically living actively in that soil, effectively eating each other. You know, it's a whole dynamic, competitive world of these 10 billion organisms all competing, you know, eating and recycling each other. So it's a very, very rich, diverse biodiversity. We as humans understand perhaps 1 to 2%. We haven't identified, you know, we recognize 1 to 2% of those organisms. So it's a zoo, and we are still, in humility, have to just marvel at what that is, because there's so much we don't understand. But let's look at the actual key thing, the functions of that soil. And actually, let's go back to the beginning again. You see, we've got just mineral soil. We've got rock. Oh, well, let's go to mineral rock. We've got mineral rock, and basically it is just made up of elements, the elements in the periodic table, effectively coalesced stardust. And it's actually the fungi that then come on and grow onto that rock and start solubilizing that rock with their acids and enzymes that actually starts creating soil. And because of that activity of these 10 billion organisms in that soil starts having functionality. It can now infiltrate and retain moisture. So rather than being an arid environment, it can actually be a sponge and start holding moisture. And of course, that moisture is then critical for making life available. So the whole global terrestrial hydrology depends on soils. You know, whether we have rivers and streams and wetlands and springs, all depends on soils. If we don't have soil, we just have rain, and it will just run off the road, and we're back to a dry desert. Okay, it is the actual property of that soil in terms of nutrition. When by breaking up those rocks, these microbes made all those minerals available. You know, they actually physically make them accessible, but also they're basically solubilizing those nutrients. And so the whole biofertility of these soils goes up as nutrients become available. Nature doesn't add any more nutrients. It doesn't need to. It just makes more nutrients available. And so it progressively increases the fertility of those soils. And then we can see very rapidly, and we see that all over the world, as soils develop, more and more productive biosystems develop on it. Okay, as these soils develop, then they also become much easier for roots to proliferate through them. And so instead of being just a surface, you know, as you mentioned earlier, just a surface film of dirt on the soil surface, we end up with, as you have in your beautiful prairie soils, 10 meters deep of organic soils with roots proliferating down to 10 meters. So if you think of it from the quantity of resources mineral resources, water resources that are now available for life, we've increased this exponentially. Okay, so basically water, nutrition, the resource availability. Now we come to another really critical function, which is actually health. You see, by having these billions of organisms in that soil, basically all competing with each other, they're actually neutralizing any disease organisms or pest organisms, so those pests and diseases can never get to dangerous population levels because there's almost so many buffering and control competitors controlling them.
Okay.
Whereas if we take an artificial hydroponic environment, or in our case, a social environment where we've got, in our case, 7.8 billion people on the planet, and then we get a virus coming into that population, and we don't have all that immunological buffering and competition, yes, we can get a pandemic. We have a pandemic.
Yes.
But the point is that's because these natural controls and buffers, which naturally limit these pandemics, are no longer operating. You see, because we've artificially destroyed the control systems, the biological controls that used to prevent these extreme populations. So the 10 billion organisms in soil are actually operating as a biological buffer control system that prevents disease outbreaks, severe disease outbreaks. Okay, and so basically from each of these things, they all add up and synergistically come together. And in a sense, that is the resilience and the productivity of soils. And we see that. We have, for example, rainforests all over the planet, the world's most productive terrestrial ecosystem, on a whole range of soils, from very fertile soils, volcanic soils in some cases, but also some very, very poor soils, sands, mineral sands, old leach sands. So the productivity of rainforest isn't dependent on the mineral richness of the soil in the sense of the amount of nutrients. It's there because of life. This biology has created these soils that allow nutrients to be made available, cycle, allow water to be available, root proliferation to depth, microbial disease buffering. So the whole productivity resilience comes from, yes, this biodiverse soil.
So just to check in so that people can follow along, we are seeing soil here as a living community, and plants are part of that community. Soil animals are part of that community. Animals that live on the surface are part of that community. Microbes, things that we cannot see, right? And my question is, when we talk about living soil, are all soils equal in the life they support, or are there conditions in which the soil carries a much greater density of population and diversity?
Oh no, David, look, there's a total continuum. You see, you can come from, yes, sterile, arid rock or hydroponic, very, very simple poor systems, to these extremely productive, biodiverse, high biofertility systems, as in rainforests. There's a total continuum. And the power is that we actually can choose where on that continuum we want our agriculture and our whole life support systems to be. Do we simplify it and reduce it back to sort of simple mineral rock and mineral hydroponics, or do we build more and more sophisticated biofertility, water retention, disease resilience, pest resilience, as we build more and more complex organic biological systems?
So if we take this to try and reduce it to very simple terms for people, we're looking at simplicity versus complexity. We're looking at biological simplicity, making systems simpler, versus embracing complexity.
and encouraging and building complexity, and in building that complexity, building the efficiency of nutrient cycles. Okay, so we're building efficiency, we're building productivity, we're building biofertility, we're building resilience through building that cycling efficiency. Yes.
All right.
But we can actually start with any soil. We can start with, just sand, silicon dioxide, dead mineral sand, and we can turn that into rainforest as we build this complexity. And the power is that we have agency. We are in control. It is our land management, our intelligence and our capacity in intelligently managing, wisely managing that land that allows us to build the bioproductivity, the biofertility, and in that way sustain and guarantee our futures.
Or in our foolishness, destroying that biofertility.
Okay, and we have that lesson is very clear. Jared Diamond, for example, makes that beautiful case in Collapse, where, yes, there's been 23 plus civilizations throughout history, and most of them have collapsed within 300-400 years because they have gone into that simplicity, degraded, mined their soil systems to the point that those soils can no longer retain the water, make those nutrients available, grow productive food. And so obviously that civilization, that population collapses unless it gets like us and becomes very, very warlike and then invades and colonizes the land of other people. So we just exploit more land. And that's in a sense what we've been doing through history. We've just been either dying, collapsing, or going into wars to colonize other people's land. But now we've reached the end of the earth. We've got a finite earth. There's no more land to colonize and exploit. So we're really down at that basics now. And unless we get wise and understand that, yes, we have to manage and regenerate the land that we've got, it's cactus.
Yeah. I'm often reminded of the book Childhood's End, and it talks about a shift in humanity where they put aside childish toys and they move to the next step in their understanding. And, what I'm struck by is when you describe all of these civilizations and we can't just say, well, those people were stupid or those people were bad. There seems to be something that as a species is hard for us to understand. And we're constantly drawn to this very powerful way of simplifying systems in order to get them to do what you want them to do. But unfortunately, there's not much staying power there.
Well, I think it's mixed, isn't it? Because basically, yes, as we build hierarchies, then of course, higher up in the hierarchy, they lose touch with these realities of soil, and the whole critical process. And so they start commanding, yes, we need more product output, but through a degrading process, and inevitably they destroy their civilizations as a consequence and have to go to war. But there are also other cultures throughout civilization's evolution which have survived. And of course, classic is, for example, the Papua New Guinea Highlanders. They've been operating for over 10,000 years, sustainably in village garden communities through organic recycling and respecting and maintaining these natural cycles. The whole of East Asia, China, Japan, Korea, again, as a culture, they've maintained over 500 million people for 4,000 years on some very, very poor primary soils because of their culture of organic recycling, always, putting the waste organic matter composted back into the soil, putting the nutrients from effluent back into the soil. And so here we have cultures for 4,000 years of sustained viable populations on those poor soils because they've had that wisdom of cycling. Our whole all societies that have survived had basically had to come to terms and develop that cycling, or, as in our case, go to war to in a sense, colonize or exploit other people's land.
And now we see in China that there's a cultural embrace of chemical agriculture. And I know that you were involved with the Green Revolution as a younger man. Could you talk a little bit about that? What were your hopes at the time, and what are your thoughts looking in the rearview mirror?
Well, look, yeah, this is really the cutting edge where we're at. Okay, in the 1960s, we were facing obviously a situation of hunger. We had some 3 billion people on the planet, and 800 million of them were actually sort of approaching famine. And so the question is, how do we increase more food production? And so, yes, we embrace some high science developments, basically in breeding plants. Well, it's actually quite a clever thing. We just bred dwarf plants that didn't put so much biomass into their stalks and roots, but put more of it into their grain, and we thought we had a big advance. But of course, because these plants didn't have as much resources in their roots, we had to then add nutrients, fertilizers, and irrigation. And so we had an agriculture that then relied on this higher inputs to get more yields. And certainly we were able to feed that population. But really, it's been very effective at producing enough food. So we do that now. But basically, it's also created problems. One, we've just increased our population. So there's now 7.8 billion of us on the planet. But in the process, we've also actually just mined the soils that these people were using. And so their biofertility, their natural biofertility, their natural carbon levels, their erosion, all of that has sort of led to deterioration. And now we're in the same situation where we've got, again, 800 million people without food security, not so much because we can't produce it, because these people can't afford it, but now we've also got, 1 to 2 billion people that are actually obese or overweight because they're eating nutrient poor foods. They're basically eating food which has got empty calories. And we've got perhaps 3 to 4 billion people on this planet who are absolutely subclinically malnourished because they're not getting the micronutrients, the trace elements that they would have got from naturally grown foods. Okay, so we actually have created a major social crisis now where, yes, we're going to go to 10 billion people by 2050, but it's the actual nutritional integrity and health of that population which is at risk because we're not producing food that's adequate nutritionally for what we need to be healthy.
So I'm going to ask to take it to agriculture, the soil carbon sponge, and climate, which is the great challenge of our time. And we'll go to nutrition, but I'm just curious. You've thought a great deal about this. Could you talk about how you see agriculture as being intimately connected with both the cause and the solution to climate change?
Look, absolutely. And it's more than agriculture, it's our whole land management, right? Because it's actually, as we said in the beginning, that's where we have agency. That's where we, Homo hubris, influence this planet for good or bad. We have the wisdom, so let's use it. And the point is that we all know that we're facing fundamental crises in terms of, as we talked about earlier, food, what have you, but also we're facing a major crisis of land degradation, where we've been basically oxidizing and degrading our lands so we don't actually have the capacity to produce the food that we really need, and certainly not the nutrition. But we also have this problem of climate change, right? Where basically we are now fundamentally changing the climate largely through our land management, what we've done over the past 8,000 years in terms of managing our land. And we see that as the increase in CO2 that Charles Keeling has shown us from 1958. So there we are. We've had that evidence all that time here with CO2 going up. And everyone's focused on the symptom, CO2. Look, we've got CO2 going up. And it's absolutely valid, there's no question about it. But we must see it, look, this is a consequence of what we've done rather than necessarily it's a cause. Because what's really happening is as we've been degrading our land systems, basically we've been changing the whole hydrology of the planet. Okay, as we said, the soils can't infiltrate and retain and make available water. And so the whole hydrology and hydrological cycles on the terrestrial system have changed. And climatology knows right from the beginning that in effect it's these hydrological processes that govern some 95% of the heat dynamics of this blue planet. 95% of the heat, we get solar energy coming in obviously continually, and basically to have a stable climate we have to have the same energy going back out of the earth, out from the earth, either reflected or retransmitted from the earth. And basically we've impeded and altered that through the greenhouse effect. So now we're retaining, instead of 342 watts per square meter coming into the top of the troposphere, we're only allowing 339 watts to go out. So we're retaining about 3 watts per square meter on average globally in the atmosphere, and that's warming the planet. And that's largely due to the greenhouse effect, which is again driven largely by water vapor and our land management, with CO2 of course contributing, and also CO2 being of course a symptom of that degradation. So what we've got to do, we've got to rebalance that whole heat dynamics of the planet. But it's relatively simple and benign because 3 watts is less than 1% of that incident solar radiation. So we've got to rebalance, these climate factors, processes by some 1%. And of course we can do that naturally through changes in our land management. And so if we look at the whole climate crisis on that perspective, yes, we can understand it. It's much more serious than people realize, much more serious, because we're now facing these dangerous hydrological climate extremes. See, when you think about it, it is storms, it's hurricanes, it's floods, it's droughts, it's aridification, it's wildfires, it's sea level rise that are actually the things that are going to impact and kill communities big time. And all of those are hydrological. Okay, it's not CO2 that's killing us, it's the actual hydrology that's changed. 93% of the extra heat that the Earth is retaining because of our interference with it is getting absorbed by the world's oceans. 71% of the planet is oceans. It's absorbing all this heat, and therefore we're getting increased hydrological extremes as more and more heat is absorbed, more and more hurricanes and changes in monsoons. All these hydrological factors impact. Wildfires, for example. Okay, so it's basically restoring that hydrology that is a critical thing, which now again comes back to soil. Okay, because it's actually soils and the sponge, the capacity of soils to infiltrate, retain, make available water slowly, buffer extremes. It's the role of that soil across the 29% of the planet that is land that is actually our means of regulating and restoring and regenerating these hydrological cycles. Okay, we have converted over 5 billion hectares of this planet and there's only 14 billion hectares of land on this planet, so that's some 40% of the land area, we have converted it into man-made desert and wasteland. Okay, the Sahara, the Middle East, Australia, Southwest US, they weren't desert 6,000 years ago, they were all vegetated. And over the last 8,000 years of agriculture and our impacts, we have created 5 billion hectares of man-made desert and wasteland. And that's no longer holding water, and that's completely changing the heat dynamics of the planet. And so the whole message is, yes, we have to regenerate the Earth's soil carbon sponge to rebuild that hydrology. And just as nature did in creating this biosystem, that allows us to revegetate these biosystems and build healthy ecological cooling cycles on them. Now, the good news is, and it's really quite exciting and it's so simple, that simply by restoring these lands, for example, restoring these urban forests or shelter woods across landscapes, we can cool those landscapes 5-10 degrees centigrade. We can buffer these hydrological extremes. So if you look at the climate crisis, we've warmed the planet now on average by 1 degree centigrade. If we get to 1.5 or 2 degrees centigrade, COP21, Paris, 2015, it's serious. It's really serious crisis. But here we are. We can cool regions 5-10 degrees centigrade just by restoring these hydrological cycles through the sponge, through reforestation.
And there are examples of that having been done.
Oh, yeah. Yeah, look, there's on both sides of the equation, David. We've got basically lots of examples where we've deforested a region in tropical areas. Malaysia, for example, 17 degrees centigrade difference in temperature between, the existing forest vegetation and the cleared land. Canberra, where I live, we're basically a global case study experiment. 100 years ago, it was a hot, dry, degraded sheep paddock, Australia, and basically the people that came, the landscape architects that came to build Canberra said the first thing we have to do, we have to build an urban forest. And this urban forest now is basically 12 degrees cooler on a hot summer's day than the adjoining landscape, bare, dry, grassland landscape. So we have that capacity both to degrade, but also to actually restore buffered hydrology, buffered cooling habitats. And so this is really powerful. This is wonderful because now we have agency. We have to say, look, all we have to do is regenerate the Earth's soil carbon sponge everywhere through grassroots, organic community action to rebuild that hydrology, to rebuild these natural cooling processes, to offset and buffer the greenhouse effect. Even the greenhouse effect, you see, we see it as the CO2 symptom. Yes, and the CO2 gases, they do about 11% of the greenhouse gas effect, but water vapor is by far the dominant greenhouse gas effect. 80% of that greenhouse gas effect is through water vapor, not through CO2, which is only 11. And we govern how much of that water is actually there by this forest revegetation, by the sponge. So we have enormous agency and opportunity, but we've got to change our mindset to realize that.
So Walter, I've heard you talk about this, but I'm wondering if you could give a 3-minute description of why water vapor is such a potent greenhouse gas. I mean, I know that a big part of the goal is to keep the land from turning into a desert. You've talked about, can we rehydrate California? And we see right here in our country, we see a large region that is slowly or not so slowly turning into a desert, and at a tremendous impact to the people who live there and the rest of the country, because a lot of the food comes from California. So can you talk about how it is that water vapor is a potent greenhouse gas, or is that the wrong way of thinking about it?
Well, I mean, it is a simple physical reality. We know molecularly why water vapor is a thing, but let's just pan back to say, well, what is the greenhouse effect, right? Because that explains it all beautifully. Okay, the greenhouse effect is governed by the amount of energy that's being re-radiated from the Earth. Okay, the sun basically impacts, or incident solar radiation impacts the Earth. And it can either get reflected back out to space, okay, or it can be absorbed. If we create a lot of bare, dry landscape, all that solar energy gets absorbed and heats up those landscapes. Okay, and so we end up with very hot, dry soils. In Australia, we get soils heating up to 70, 80 degrees centigrade, whereas in a cool, forested, protected environment, those soils are rarely above 20 degrees centigrade. This has a profound effect, because there's a simple law of physics, the Stefan-Boltzmann equation of black body radiators, that the amount of re-radiation from a body like the Earth is governed by the fourth power of the temperature of that body. So a surface that is bare, dry, heating up, and at 70 degrees centigrade retransmits, re-radiates massively more heat energy up into the air than a cool, moist, protected landscape at 20 degrees.
Yeah.
Okay, and that re-radiation is what drives the greenhouse effect.
Yeah.
Hang on, I just had a little thing with the computer. That drives the greenhouse effect, you see. And so then the question is, here is the quantum of re-radiation going up, which is massively higher because we've disturbed that land surface. And then the question is, how much of that re-radiation that's been emitted from the Earth is absorbed by gas molecules in the air? And there's two main greenhouse gases: water vapor, which, as we've said, absorbs 80%, or has 80% of that absorptive effect; CO2, which has 11%, and there's a whole range of other gases, methane, nitrous oxide, etc., that collectively do about another 9%. But water vapor drives 80% of that gas absorption. And the point is that we control two of the dominant variables. We can control how much re-radiation is coming up from the Earth through our land management, if we keep it protected and cool, and we can govern how much of the water vapor is in the air for how long, again through our land management. We can't actually, in the short term, do very much about the CO2, because it'll take hundreds of years, even if we stopped all fossil fuel use, for that CO2 level to come down. So we don't have agency over CO2 in a practical, effective, short-term way. But we have total agency over the amount of re-radiation being given off by the Earth, simply by land management, land protection cover, and we have agency over the water vapor. We can have agency there within days, within weeks, whereas it'll take centuries to influence the CO2 level. So that's, in a sense, where the link is between land management, soil regeneration, and actually cooling the climate and restoring a safe, buffered climate to secure our future.
So you have said that we have great agency over these outcomes, and I understand that on a physical level we do, and that if we all made different choices, we could live in a very different world very quickly. But I also see that it's actually quite a challenge to get us as a species to do things differently. And there's a lot of craziness. I would call it probably the religion of money that is a compelling thing that drives so much of our decision making rather than our survival as a group. One thing that Al Gore said that I thought was very strong is he said, basically, it's very important to change the light bulbs, but it's more important to change the laws. And that in the end, the laws will only change because we, the people, change. So what you're talking about is an important message, because people need to change their understanding in order to change their behaviors. But I also see that somehow we have to create movements so that rather than one person individually changing, okay, they ride a bicycle instead of a car, fantastic. And they have completely shifted their contribution to climate change to a different place. But ultimately, because the problem we face is created by many of us in concert, we have to somehow create a change by many of us in response. And I think that requires a movement. Have you got any thoughts about that?
Well, yeah, dilemmas actually, and thoughts, of course. Yeah, no, look, you're absolutely right. That's the crisis, isn't it? Like whether we as a community now can actually influence the changes and catalyze the changes that we need, or is there so much inertia and vested interest and protection within the existing system that it basically can't change? That we totally disempowered ourselves and the system won't change. And of course, if that's the case, then yeah, that's a recipe for collapse. That's why Jared Diamond, 23 of these civilizations throughout history are being found in the dust of archaeology, right? Not as living societies, they're dead. Okay, and so we have that simple choice. But the point of agency is, as you said, David, it's understanding. Okay, it's basically just panning back and looking at, well, look, how did nature create this biosystem? How does nature create and regulate the climate? What are the factors? And then where is it that we have agency, which is exactly what we've been talking about. Like where is it that we can influence land management, the area of desert, the amount of re-radiation, the whole dynamics of water in the air. And so that's how nature does it. The question is, can we do that as well? But coming now to Al Gore, yeah, we can't do that if we disempower ourselves and say, oh, we expect the government to do that for us. Because obviously a government is always looking at 3-4 year short-term opportunistic self-interested cycles, and it may not have the license to actually look long-term strategically. And so it really comes back to the communities, doesn't it? Like, how do we as a community in a democratic, polis say, look, we are in charge, we are responsible, we are also responsible. And then say, what is it that we can and must do as a community at the grassroots level to affect these changes? And again, this is why soil is the critical agency, because it is we, the community, that controls what happens to every square meter of soil. It is we, as a farmer, that controls what happens to my acre or my 100 acres. It is we as a local community says, look, what are the farming systems, forest systems, land management systems we want in our county? You see, and it's there that we have that agency, and it's grassroots community empowerment enabled by that understanding. And what we're trying to do is we're just trying to widen the toolbox. We're widening the actual options that we have for that grassroots agency. We have spent, Charles Keeling, 1958, basically gave us the warning. It was very clear by the 70s, here's CO2 going up. So we've spent 50 years just in denial and delay and talk and more research and more warnings and 25 COP meetings, right? Talking and warning, but the point is there's no action. And it won't be any action, and clearly the whole process is going to no action until we do what Antonio Guterres is telling us. We've got to get back to these natural climate solutions, these grassroots empowerment of, democratic civil action regeneration. And the means to do it is regenerating the Earth's soil carbon sponge, the longevity of green in our landscape, and that will automatically, as in nature, kick in the hydrological, cooling, buffering cycles to restore this climate, and we can do that within decades.
Thank you for listening to the Real Organic Podcast. We hope that you will subscribe, tell your friends, and leave us a rating and review. A video version of this interview, as well as the full transcript with links related to our conversation, can be found at realorganicproject.org/episode 38. Please join us next time when we continue our conversation with Water Jehne and move beyond soil and climate to focus on nutrition. To find a Real Organic farm near you, visit realorganicproject.org/farms.